Now we're going to work on the same data set we did with the linear modeling approach, and we're going to apply the KNN regression. So KNN we had used before. It's sort of a multi-use tool. Here we're going to use the regression approach, and what that does is look for similar companies based on these distance measures, and then the prediction is the comparison companies is the prediction for each observation. So to make it simpler, I have a training data set and a testing data set that are available. It's just prepared and simplified so that you don't have to do all the stuff we did last time. So we read in those data sets. We're going to introduce a few new tools again. So how do we create a function? Here I'm going to create a standardized function. So notice I've created an object. That object is going to be a function. Assigning to that object the object is named SDC. Assigning to that object is this function of x. So we tell it it's a function. That's what that command is. Then in parentheses we have to tell it what objects are going to go into that function. And so when we use that function later, we'll put in whatever is going to be input into that function. And so it could have other things here, y, z. You could put in other things into that function as well. Then in the curly brackets is all of the part that the function that we're going to perform on whatever is the input to that function. So here the input is going to be x, and I've created a function that works on x, and the last thing that you are going to that comes out of a function is what gets output out of the function. So if we had something else here, like x2 object is from x, and then x is, or x2 like mean of x2, we have other things going on. The last thing is not an object. The last thing is the thing that we output out of the function. So here notice I'm not saving it as an object. That's because that's what's going to come out of the function. And then these are things you should recognize. So I'm doing x minus the mean of x, and we use na.rm equals true, meaning remove any missing values before doing the mean. And same thing with the standard deviation. So this is the same standardizing function we've talked about, but I'm just creating it through a function. So created a function, notice that showed up over here as a function. Now we have SDZ as a function to work with, and if we open it, it shows us what that function is. Okay. So we're going to use the training data set, and there are some variables that we want to standardize. So I've already taken care of taking the natural log and removing outliers. So we have objects that we can apply straight away. So we're going to standardize. Notice I'm doing by year, and then the mutate creates a new column, and so I'm going to do PMS is the standardize. So all of these have S's after them. And how I call that function is the name of the function and then whatever goes into that function. And here X is going to be profit margin. And then the same thing with each of the rest of these. The reason we are doing this is because on the KNN approaches, if the variables are not standardized to have similar distributions or similar magnitudes, then the largest ones are going to drive the KNN differences. So we should always standardize when we're dealing with these types of approaches. So we're going to do this here. We need to standardize also on the testing data set, primarily because we need the same variables available when we go to predict from the testing data set. All right, we're going to introduce a couple packages here. So Caret is the package we're going to use, and the Caret package, what it does is train models, and in particular it's focused on machine learning approaches, and it tries to go through and select parameters that make the model work well. So it's a training machine learning package, and so we're going to do a few things from that in this video and the next video. So to get it set up, we need a data set that is just the x variables. So here I'm going to use these 4 x variables. These are the ones that I had in the prior video, but these are standardized now. So I'm going to take the training data set, select only the x variables. So now I've got the training x variables. So I have this object train x over here. Just for interest, to keep it consistent, I'm going to do train y. You'll see we don't actually need to do that one, but now I've got an x data set and a y data set. Another thing I'm going to introduce here, and you don't have to do this part, and it'll work just fine without it, but sometimes you're going to have things that take a long time to run. One of the ways to improve that is to run them in parallel, meaning like you have two computers, you run one piece of the machine learning method on one computer, another piece on another computer, and that's called running things in parallel. Well, the package do parallel allows us to do that. So a lot of computers nowadays have multiple cores, so here I'm just going to use this detect cores function. I have 16 cores on my computer, so I can run up to 16 parallel versions of the machine learning method. But you don't want to use all of them, otherwise your computer will sort of not run anything else. So you create a cluster, so that's this function here. I'm going to use 8 cores, and see this object is the thing that is the cluster. So I'm going to make these. So it's going to split up all of these cores into different objects that it can use, and then register do parallel takes this object that is these different clusters and starts up the parallel running, basically. So a lot of these methods that we will use can run things in parallel. You can tell it to run in parallel or not run in parallel. The default is to run in parallel. Okay, so KNN regression, where you have to introduce a bunch of things from the caret package. The first is we're going to set the seed so that we can have the same results when we run these things. I've seen that not everything is always perfectly the same, depending on which package you use, but most of them will force the results to be the same. Okay, so we have a few things we need to work on. So the first is, let's go with this part, and this is the one that trains the model. So see how it says train here, and the input to that is the y variable and then the x model. So here I'm doing the y column, so I'm telling it go to train x and get the column interest rate. We could do that just with the train data set as well, so that's why it's not very necessary. Then the x data set has to be all of the x variables. So we just put in train x. This is a data frame or a matrix. And we can also put it in a formula format just like we did with linear model, but we'll stick with this for a while. Then we have to tell it what the method is we're going to use. Here we're using KNN regression, so the function is KNN. The caret package has a lot of different models you can train here, something like 100 plus. So if you want to use different models or explore different models, you can do them. I will show you several that you can use. Okay, so we could just run this, use it up through this part. Then there are other things we can put in to control how these models are estimated. So this first one, this train control, I'm inputting into that control, so control is this object up here. So I'm just using it so I can change this and then not have to type it all in here again. But what it is this train control function, and it tells it things to do. And all of these have some defaults, and you can override the defaults by telling it what to do. And this repeated CV is repeated cross-validation. And so what that does is on the training data, take a part of the data set, estimate the model, and then see what happens when it goes to a new data set, like the piece that it broke off. And repeats means go through this process 3 times. And there is another part that you'll see in the next video as well. But this basically says go through it a bunch of times, and it's sort of like having a testing data set in the training data and repeating it over and over and trying to fine-tune the parameters that go into the the modeling method. Here in the KNN regression model, the parameter that we're interested in is K. So it's going to go through different K levels and try and find the K level that best fits the training data set. Okay, so we're gonna run this. So we set up this control, run this. So you saw I had a conflict in packages, so this is a good place to explain that. So when sometimes one package requires a certain version of another package, so I had to go through when I did the read in the carrot library, I needed to update these other packages. It said you need a new version, so the way to do that, you could try update, but I don't always have success with that. So you, if you remove the package, then reinstall the package, it will install the newest version of it. So I had to reinstall 3 different packages. Now once I have it, things work fine again. So let me go back to here. So we will run this, set the seed, do the controls. So I'm going to do the repeated cross-validation and estimate this model. So there are other things we can do as well, and we'll show more on the next times we run this. I tried to set up all of these models to be somewhat fast. So there are many things you could put in here that could run even longer, and really you might create some models that run for a long time. Here I'm doing the simplest ones possible, and especially in the next video, I'm going to simplify things to the minimum possible while still doing all of the steps. So here we'll let it run for a while. We might want to look and see how long it takes, but we're going to, we wait until it runs through it, and it will depend on your particular machine. So this took about 10 minutes on my machine, so may take more or less for yours. In the next video, we'll make sure we cut things down so it doesn't take too long, except there are a few that take a while. Next thing we can do is look and get some information about the model. So the difficulty with machine learning models is they generally don't give you the information that you might be interested in, like in the summary of the linear model. But we can get some information, output this model here, and it'll tell us what it did for that model. So notice it said it tried k nearest neighbors, it had 4 predictors, it had this many observations, it didn't pre-process. That's something we'll get into next time. The resampling, meaning going back for cross-validation, did 10 folds and repeated 3 times. So by not putting in the number, then it used 10, and that's the default. So next time we'll cut that down to make it faster. So if we used only 2, for example, it would be faster. And then these are the different results for trying different parameters. So it tried 5, and the root mean squared error is bigger values are worse performance. R squared is bigger values are better performance, and so it stops once it gets to a point that it thinks it's not improving anymore. So notice the root mean squared error went down, then went down again. It's slightly better, so the R squared went from 4 up to 5, and then it said going up to 10 didn't help anymore, so it stopped at 9. So it chose 9 as the K value to use. And that's what it tries to do, is go through and find the right K. So we can also plot this to look and see sort of visually what happened. Notice the root mean squared error, it was higher, it got better as we went down. Well, if we wanted to, we could force it to go even further to see what happened at 10, 11, 12. But it improved as it went, as we added more K to the model. So that's all we can tell. So what we can then do is try and see, notice we have the R squared here that it outputs. It got to a 5%. Well, we can do something just like that by creating the fitted value and then creating something like an R squared. The reason we're going to do this is because this allows us to evaluate the model when we go to the testing data set. So first we're going to predict, so this is using the model to predict values. So we're going to predict with the model that we already estimated. So notice this is the same as up here. We created a model, and then now we're using it to predict. And the data we're going to use to predict on is the training data, so the X values from the training data. We could do this with other data, right? We could have a single observation of X's here, or we could have the testing data here. but we're using the model on a data set. So we do this. Notice so for every observation of the x's, it's going to give us a y predicted value for the interest rate that we're predicting. Here I'm calling it fitted because we've already estimated the model on this, so it's not really testing how good the prediction is, it's testing how well the model fit on that data set. Then it's, at least for the KNN model, other models can be a little faster, but the KNN regression, now it has to go through this data set, find for every observation 9 similar observations, to then make the prediction for what the interest rate should be. So because it has to go through every observation and find every comparable value, this takes a while. So again, we ran the model, it took a while. The prediction here is going to take a while, so we'll wait a little bit while it finishes. So that took a few minutes on my machine. Now what we want to do is, once we have this fitted value, we want to see how closely it maps to the actual value. So again, I'm going to create a function here that it's going to simplify every time we do these fit tests. So I'm going to call it fit test, and the function it's going to input into it is this actual thing that we're predicting, and then the prediction that comes from the model. So this fitted interest rate is going to go into this predicted, and then the actual interest rate is going to go in here, and we're going to output something that is like an R-squared. And an R-squared is how well does the model fit the data. So here, this is just the formula for that. So this is, up here is the residuals, so how much variation is there in missing the prediction compared to the variation in the actual interest rate. So I don't care that you memorize this sort of fit model, but it's something like an R-squared. It's slightly adjusted, but it's basically the same idea. So we're going to create this and then run this function with the fitted interest rate. This is the thing that's predicted, and the actual interest rate, which is taking the training data set, the y variable there. So we run this, and what comes out of that is something like an R-squared. So it says 66% of the variation in interest rate our model picks up. So seems like it fits the data fairly well. Well, we could do the comparison. Let's go back and do the linear model that we had before. So this linear model. And it's similar, the data is a little bit different, but basically the same. So then higher profit margins have lower interest rates, higher leverage has lower interest rates, and higher assets have lower interest rates. So why is this different? Well, we use different cutoff points. So the data that you have in this data set has different cutoff points than we did in the last video. So now it looks all nice because we cut it off the way that happens to work with this data. That should make you think that the outcomes are a little bit sensitive. So, but anyway, it doesn't make you super confident that the data is what we hope it is. But it gives us something to work with. So then we're going to do the fitted interest rate again. This is with the linear model. So again, take that model, apply it to this data, and now we've got a forecast or a modeled value, and do the same thing. Well, notice the model value for the linear model, the fitness of that model is 60% compared to the 66%, so the KNN regression fits the training data slightly better than the linear model. Well, then we can do the same thing going to the testing data set. So here I'm going to create the x variables for the testing data set. So we're going to select those x values for just the testing data and do the same thing we did before. So now I'm calling it predicted instead of fitted because we haven't run the model on the testing data. We're going to take the model that we trained on the training data and apply it to predict for the testing x variables. And we're going to create one for the linear model and for the KNN regression. And again, remember that when we predict with the KNN regression, it has to go through all of them, so it'll probably take a few minutes again. All right, didn't take quite as long, and that's because the data set isn't quite as big, the testing data isn't. All right, we've got these predictions. We're going to do the same thing, but now on the testing data. So we've got this prediction. We've got the actual interest rate that occurred on the testing data. We're just going to see how they work. The first one is the linear model one. The second one is the KNN regression. And notice on the linear model, 2% on, or 2.2% on the KNN regression, 2.5 or 2.6%. The big question is that big enough of a difference to go through the time that it takes to run the KNN regression? And that depends on the particular application that you use. But at least we see, so there is some improvement going for the machine learning method. The big thing you should notice is we got, around 60% R squared on the training data. When we get to the testing data, we significantly do worse, and that is sort of standard, is that a lot of the things we try to predict, the models do a great job of explaining what's happening on training data, but when we move to predict to different data, the model doesn't work nearly as well. And there are some things we can work on to try and improve how things work on new data, but it still is a huge challenge getting models that will work on one data set and then again work on another data set, and that's the huge issue in machine learning. All right, you can mess around with some of this some more, but on the next video we are going to introduce other machine learning methods and a few more tools within the carrot package.